speaking, not from either of those. It's coming from the mashup middleman site itself. So there's the potential for maybe if you have a housing site, for example, and people come and look at that, look at it on Google Maps and say, oh, I want to go to an area with a lower area of crime. Now, how do you know that the mashup site, the middleman there, isn't trying to sell you his house, is editing that data on the way through to you and saying, yeah, my area is in the lowest crime area, buy my house from me for an inflated price? And it really comes back to, again, you might trust the individual sources of data, but you're not getting it from those. You're getting your output from that middleman. From a widget point of view, I've used iGoogle here, but you can see it's essentially a way of pulling different little applications or bits of code or however you want to call it to give you that customized kind of page. So, giving you access to your emails, stock prices, news, calendaring, and so on a single page. So again, it's really just multiple applications, like I said, different components. The problem can come, though, is if you have a shared DOM model between all of those widgets. So if I have my Security Ninja widget up here, and you've got your stock price and your email widget down here, and we're in the same DOM, then my widget can potentially read your emails or make stock trades on your behalf. Because whilst they're all within that same DOM, I can also access any of the document dot whatever elements from my Security Ninja widget. So for your cookie or even doing things like key login, stealing data, as I said, from your Gmail widget. And I think more important than that previous point is that these widgets are developed or can be developed and uploaded by literally anyone. And anyone could include malicious users. Now, there's not a sign on iGoogle saying, yeah, this is a malicious widget, don't install it. That's down to you as an end user. And I've got an example of a Facebook application I want to look at in a minute, but what Facebook's saying in their terms and conditions is basically we're not going to review any of that. If there are security problems with any of these applications, it's down to the users themselves to report that to us. So again, you install these very much at your own risk. So in Facebook, there was an application called the Secret Crush application. And basically, you got a message pop up saying someone's got a secret crush on you. Do you want to go and find out who it is? If you want to go and find out who it is, click here. Oh, surprisingly, you have to install this application as well to find that out. You install it, and then an iframe pops up afterwards. Now, this iframe wasn't pushing malicious data directly itself. Basically, what it was saying, well, now you've got your Facebook application, do you want to install this other thing from us as well on your desktop? And the iframe was being served up by a company called Zango, who are quite a well-known spyware company. So if you install that on your desktop, you've got spyware down there. So really, like I said, it prompts you to install spyware. They managed to get that on 4% of all the Facebook profiles, so 4% of 250 million users. And probably at the end of the day, none of those users really loved you. Only Zango probably did, and that's not really a good place to be. I'm going to have to fly through these last few now, but next up, information leakage. Really what we're talking about here is if your application crashes or someone does a SQL injection attack, you don't spit out internal information back to the user. So a simple example here, we've got a URL, I throw and user columns equals 2 on the end, trying to do a bit of SQL injection attack. We don't handle the error properly. It spits out this internal SQL error message back to me. So yeah, real simple example there. What can make this worse in Web 2.0? Well, we have the idea of publishing things like WSDL files. And what a WSDL file is it essentially defines how and where you can access web services. There's a lot of information in there that makes it easy to people to come and use your web service. It also makes life easier when I want to come and hack your web service as well. We're also doing a lot of kind of business logic, validation, storage of data down on the client side as well. And again, we're going to look at 2 quick examples here. So my Google hacking skills, not really fantastic. I don't think I'm going to replace Johnny iHack stuff yet, but we're doing a file type WSDL search. You can just go and look at these WSDL files and you can see people straight away here saying, yeah, here's the technology I use in the back end to create these files. Again, not going to bring the house down by themselves, but if I'm trying to fingerprint your infrastructure and find out what you're doing, it's a little bit of a help there. And this one here also made me laugh a bit as well. Now I don't have to try and figure out how you're validating my data because you're telling me up front. So you're telling me I'm going to take your email address, this is the amount of character space you've got to play with, and here's the pattern I'm going to match that against as well. So I don't have to bang my head away on the keyboard. I can just go and grab your WSDL file and find that out for myself. Another quick one here, if we're doing validation of data on the client side, always back it up server side, and never assume if you're storing sensitive data on the client side that it's going to be safe. So the Macworld conference found that out the hard way in 2007. Basically, in the client-side JavaScript, they had an array of hashes. And what was happening here is when you went to buy a pass for the conference, there was a special codes field. When you put anything in that special codes field, it checked it against these values. So the researcher looked at it and thought, well, okay, let me see if I can brute force one of those values. And he brute forced one of them in like 10 seconds and got a $2,000 platinum pass to the conference. When there's money involved, that kind of money, don't do silly things like that. I think they got caught out the following year again by the same researcher with something very similar as well. So yeah, it's not a good idea. Authentication and authorization flaws, really making sure that whoever's using our application is who they say they are and not accessing things they shouldn't do. So with authentication and authorization, we're looking at things like, making sure that passwords have maximum age, reasonable lengths. If we use things like capture systems, make sure it's not just there to look pretty, that it's actually a useful capture system. I was using a website back home before I came out the other day, and they had 4 numbers in the capture, and they had 2 little red lines, one above the numbers and one underneath the number. It's not really obscuring the capture at all. So if you're going to use it, make sure you use a decent one. It's not easy to get right. Microsoft, Google, Yahoo, they all push capture systems out there that have been broken. So if you're going to put that out there, make sure it actually does something for you. From a session management point of view, make sure your IDs have sufficient entropy, so every character is random enough. Don't have predictable session IDs, don't reuse session IDs, and so on. A flaw I found in Facebook earlier this year, which allowed me to bypass the prevention, the security mechanism, they had on accessing people's picture albums. So what they found out is they had a very predictable URL to access photo albums. So the URL just had 3 parameters. It had an album ID, a user ID, and an L equals value. And the L equals value is the only unique value in some instances. So everyone's profile pictures album always had an album ID of -3. So I don't have to guess that. The user ID value, I don't have to be your friend or anything to get that, and just do a search for you in Facebook, hover my mouse over the add friend link, and I can just see your user ID. So I'll pop that in there. So again, I don't have to try and brute force that. So I just needed to brute force the L equals value. They used 5 characters, A to F, 0 to 9. It didn't take the Burp Suite very long to brute force those for me. If you go to my blog, you'll see that they did fix it, but they fixed it very badly. So the example I'm going to show you in the Burp Suite now would still apply. It would just take a little bit longer. So really what I did is I loaded the URL up into Burp Suite. I'm sorry that the pictures are a little bit fuzzy, but like I said, if you go to my blog, there's a full write-up on the Facebook issue there. The 2 red values is basically I'm saying brute force those 2. It went away, brute forced them, found a genuine URL for me. I threw that into the browser and I could access Bobby Table's photos. I'm not logged in, I'm not his friend, anything like that. So again, it worked for different albums and so on as well, but you had to brute force the album ID value and so on. But as I said, if you go to my blog, search for Facebook, it'll be all up there. What makes it worse in Web 2.0? If we use capture systems that don't provide actually any increase in security, then they might as well not be there. More access points in Web 2.0 makes it more difficult to identify weaknesses. Using things like single sign-on, your Google account, one username password for loads of sites. Its selling point is also its biggest security issue in my eyes. And then growth in some of those other attacks, so cross-site scripting, for example. You might have the most random, longest, strongest session ID in the world. If you've got a cross-site scripting vulnerability, they can just grab that anyway, and it doesn't really matter. running out of time here, guys, but insecure storage and communications of data, really not encrypting data when you're storing it or transmitting it, using weak protection mechanisms and so on. Those types of things are what I'm talking about here. What makes this worse in Web 2.0? More data in more places, including the client side. We saw that with the Macworld vulnerability before. If you can't be confident about securing it, don't put it in that location is pretty much the answer. And when you mix secure and insecure content on a single page, the insecure content can undermine the secure content security. There's a talk by Sam Bowen and I think Robert Hansen as well at 3 o'clock today. I think that's what they're talking about, so go along and look at that. Kind of what makes my job harder, Web 2.0, more code, and the applications are largely more complex. It has to be generally more than one language as well now. So people are using the best language for the job, so JavaScript down on the client side, PHP or whatever on the server side. Just little differences between languages, even right down to if you look at your regular expressions you use for input and output validation. Different languages have slightly different formats or syntaxes for their regular expressions. So it's more of just getting all those little bits right between different languages. The dynamic nature of the pages themselves in Web 2.0, a single page could have many different representations of that page because we create them dynamically with things like, manipulation of the DOM. It's difficult to make sure that you've tested every type of page A, for example, and then the increased amount of input points makes it more difficult to make sure you're validating every input that comes in. How can you prevent these vulnerabilities? One of the approaches that I take, and if you want more in-depth information on these principles, if you go to my blog, I spoke about them at Security B-Sides on Thursday, so there's a whole PowerPoint up there for that. But really the idea that I try and push is not to try and prevent specific vulnerabilities, but just develop securely, and prevention of loads of vulnerabilities will come out of that. So what I mean by that is the secure development principles: input and output validation, make sure you've got error handling, strong authentication and authorization, session management, secure communications, secure storage, and secure resource access. As I said, if you go and grab that other presentation, there's a lot more information on these. And then just visually here to finish off, secure development doesn't happen by accident. You need to plan it right at the start, have it in your requirements and design documents, do things like threat modeling, educate your developers. Don't just assume that you're going to be able to develop securely. Educate them so they can build security into the code, make it part of the application's DNA. Think of it as you make it part of its DNA instead of trying to put a coat around it at the end, because it will fail if you try and do that. Get someone independent from yourself to review the code, and then finally try and hack it yourselves before it goes live. So thank you very much.